All right, good afternoon, everybody. Okay, so today we want to look at radioactivity. All right, so we want to look at radioactivity in today's class or nuclear physics. All right, so what is radioactivity? Radioactivity is the spontaneous disintegration of a radioactive atomic nuclei, all right, by the emission of alpha, beta, or gamma particles, all right, or any of the combination of the three. So the emission of radioactive atomic nuclei, all right, or the spontaneous disintegration of radioactive atomic nuclei with the emission of alpha, all right, beta, and gamma is what we call, or any of the combination of the three is what we call radioactivity. Okay, now these are the three different things that can be emitted, and the symbol for alpha particle is helium, helium 42. Beta is electron 0 minus 1, then gamma is neutral. Alright, so this is what we have in radioactivity. So now the radioactivity or radioactive elements are called the group 8 elements. They involve, e.g., we have helium, examples of radioactive elements. Radioactive elements are actually the elements, alright, that spontaneously emit um nuclei. All right, we have helium, we have thorium, we have uranium. All right, we have xenon, we have uranium, we have thorium, we have xenon. These are the examples of radioactive elements. We have xenon, we have polonium. All right, and we have etc. We have many other radioactive elements. We have argon too. All right, we have krypton. Argon, we have krypton, etc. So these are the examples of what so radioactivity is defined. I'll give you a definition and said that radioactive elements are group 8 elements or group 0. All right, they are called the inert gases. Okay, and they are the element that spontaneously emit radiation, and these are the examples of such elements. So these are the particles. This is an alpha particle. This one is a beta particle. While this one is a gamma radiation, and anytime you have two kinds of reaction, the first study of radioactivity was done by Becquerel, right? Henry Becquerel. Becquerel did his first study of radioactivity, and that study was in 1896, all right, which Marie Curie and Pierre Curie later completed in 1898. All right, the first study that was done by Henry Becquerel was in 1896. All right, then Marie Curie and Pierre Curie completed that experiment in 1898. That is 2 years after 1898. That is the introduction to radioactivity. And they use uranium compound, all right, just like X-ray. X-ray photographic plate was used, all right. Then here, what was used to discover radioactivity is what we call uranium compound, all right. They place it on the photographic plate, all right, and they discovered that a light proof paper caused the plate to be exposed. So further theory or experiment was performed on that, and reactivity was discovered. So in reactions in radioactivity, or what we call nuclear reactions, there are two kinds of reaction. Okay, but before I delve into the two kinds of reaction, let me tell you the properties of each of these particles. So I said we have alpha particle. All right, alpha particle, that was the first particle I mentioned. So what I'll just mention three each. What are the properties of alpha particle? What are the properties of beta particle? And what are the properties of gamma radiation? So let's talk about the two first. Now, for alpha particle, the first property you can note them. Alpha particle actually ionized gases. That is the first one. All right, they are ionized gases. Number two, they move with high velocity. All right. Then number three, they have little penetrating power. All right, so they can be stopped by substance like paper. All right, I said the practice of alpha particle, which I said its symbol is helium. All right, 2 4. Helium, we have 2 here. The proton number or the atomic number is 2, while the mass number, the sum of the proton and the neutron number is 4. All right, the first property is that they are ionized gases. Number two is that they move with high velocity. Number three, they have little penetrating power. Then they can be stopped by substance like paper. Then number four, they are helium nuclei. All right, that is helium nuclei. So I've given four properties of alpha particle. So for beta particle, before we move to gamma radiation, gamma is a radiation, all right. Gamma, this is gamma, GAMMA, gamma radiation. All right. So now, what of for beta particles? No. What are the properties of beta particles? The first properties of beta particle is that number one, all right, the ionized gas is lesser in a lesser extent than alpha particle. All right, they also ionize gases, but in lesser extent than alpha particle, because alpha particle also ionizes gases. The number two is that they are of high velocity compared to alpha particle. They move with high velocity, all right, than, because alpha particle also move with high velocity, so this one move with high velocity, all right, than alpha particle. Number three, they have more penetrating power as well than alpha particle. All right, these ones cannot be stopped by paper. Then they are negatively charged. Alpha particles is negatively charged. Then they are strongly deflected by magnetic field. All right. What is deflection? Deflection is actually the change in direction of a substance when it passes from one medium to another medium. So they are beta particles are deflected by magnetic field. All right, that means their speed changes when they move into magnetic medium. So they are relatively light. All right, they are light. All right, electron negative 0 minus 1. So they are light. Take note of that. These are not particles. They are negatively charged, and those are all of the properties. They move with high velocity, high penetrating power, and they have they ionize gases in lesser extent to alpha particle. All right, they are deflected by magnetic field, and they are relatively light. Right. I've done the concept of light in optics in our photoelectric effect. So lastly, the last particle is what we call gamma radiation. All right, what is gamma radiation? Now, gamma, or what are the properties of gamma radiation, which is neutral? The first one is positive, the second one is negative, alpha is positive, beta is negative, then gamma is neutral. So the first, all right, about gamma, or properties of gamma particle is that number one, first properties of gamma particle is that number one, they are electromagnetic wave of short wavelength. All right, so this one, we know the spectrum, all right, RIVUSG. All right, I think we have MI rather. All right, we have radio, we have microwaves, we have infrared, we have visible light, ultraviolet, gamma ray. Then we have what? X-ray, and we have the gamma ray. This with increasing frequency and decreasing wavelength. So as the frequency is increasing, all right, then the wavelength lambda is decreasing. All right, from radio to this RMIVUSG, radio with microwave, infrared, visible light, ultraviolet, gamma ray, X-ray and gamma ray. So as the frequency is increasing in this order of spectrum, the wavelength is decreasing in the order of spectrum. So gamma ray is the last part there, which has the highest frequency and the lowest wavelength in all of the spectrum written there. The eight spectrum, yeah, or seven spectrum over there. So